Okay, so to find the asymptotes of a rational function, the asymptotes are where you have an excluded value which doesn't get reduced. So to find the excluded values, we factor the denominator. This one's a difference of squares. Okay, so when x is -2, the denominator becomes 0, and when x is +2, the denominator also becomes 0. Right, so I can check here, -2 squared is 4, minus 4 is 0, or when x is +2, 2 squared is 4, minus 4 is again 0. Okay, and the numerator is just 3, so that's not going to cancel anything out. Okay, so I know that there's a vertical asymptote at both -2 and 2, so that just leaves these two options. So what about the horizontal asymptote? The horizontal asymptote, we look at the degrees of the numerator and denominator. The numerator has degree 0, there's no variable visible, and the denominator has degree 2 because it's x squared. So when the denominator has the bigger degree, that means that as x gets very far away from 0, the denominator basically overpowers the numerator. So when you have a fraction in which the denominator is much bigger, its value is going to be close to 0. Right, we can just plug in a value for it if we don't remember the rule. So let's just pick x as 100. So when x is 100, we get 3 over 10,000 minus 4, 3 over 9,996. So then if we wanted to do that as a decimal, right, we see that it's practically 0. It's very, very low. So whenever the denominator has the greater degree, the asymptote will be y equals 0, assuming there's no shift. Okay, asymptotes over here. So again, vertical asymptote, we just look at the denominator's excluded values. So when I plug in -3, -3 plus 3 is 0. Okay, what about the numerators? Well, so this is really 1x over 1x. So these have the same degree. Numerator has degree 1, right? It's x to the first power, and denominator also has degree 1. So when your numerator and denominator have equal degree, you divide their coefficients. So in this case, it's simply 1 over 1 equals 1. So y equals 1. Okay, so why is that true though? Well, let's just pretend we had 8x over 4x. Again, these are equal degree. So when I reduce this, it simply becomes 2, right? The variable parts will divide to 1 if they have the same degree, so we only care about the coefficient part. Okay, so again, this is a separate example. Okay, where's the whole? So we want to start by factoring. Okay, so both -4 and 1 are excluded values. But then this gets reduced away, meaning that this 1 will create a hole instead of a vertical asymptote. So the x-coordinate's 1, what about the y-coordinate? So I just substitute in the x-coordinate into the reduced version. So x plus 2 becomes 1 plus 2, x plus 4 becomes 1 plus 4, so that's 3 over 5. Okay, so I made a typo and this isn't an answer, so I said the choice is C, so we're going to have to change that. Okay, so again, another whole problem. Let's start by factoring the denominator. Okay, so this time excluded values of -5 and -2. Okay, so the x plus 5 is on both numerator and denominator. So -5 will be a hole instead of a vertical asymptote. Okay, so I'm supposed to substitute in -5 to the reduced rational function. So since there's nothing left in the numerator, I know it's really a 1. So substituting -5 into here, we get 1 over -5 plus 2 becomes -1/3. So -5 comma -1/3. Okay, what's the domain? So the domain is all the x values which are not excluded values. So I need to factor the denominator to do that. Okay, so one strategy I can use to factor, I put the x squared term and the constant here. So I know that these multiply to negative 6x squared. And then they must add up to the b term, the x to the first power, which is negative 5x. Okay, so but two terms multiply to negative 6x squared, but add to negative 5x. So the one with the greater absolute value has to be negative if they add to a negative. So negative 6x and positive 1x fit. Okay, and then now we factor by GCF. 2x squared and 1x, the common factor is positive x. Okay, negative 6x and negative 3, common factor is negative 3. 2x squared minus 6x, common factor is positive 2x. And then x and negative 3, common factor is positive 1. Okay, so denominator factors to 2x plus 1, parentheses, x minus 3. So the excluded values will be what makes these 0. So over here, if x is 3, that's an excluded value. And over here, if x is negative a half. Okay, so these are the two excluded values which are not part of the domain. So I want the domain to get split up at negative a half and positive 3. Okay, so that looks like choice B. Okay, what's the domain over here? So again, let's start by factoring. Okay, so in this case, it looks like the x minus 6's could be canceled out. But remember, 6 is still an excluded value. It just creates a hole instead of a vertical asymptote, but it's still a excluded value, meaning not in the domain. Okay, so I want my domain to get split up at negative 1 and positive 6. So that would be C. Okay, solve rational equations and inequalities. Okay, so I want to get a common denominator here. So let me just rewrite it with a little more room. Okay, so 5x minus 20 could be rewritten as 5 parentheses x minus 4, which helps me see what to multiply by. So this term over here, it's got the x minus 4, but it's missing the 5. This term over here has the 5, but it's missing the x minus 4. And this one has everything. Okay, so over here we have 10x. Okay, so now you gotta be careful here because this negative affects the 3. So negative 3 times x is minus 3x, but then negative 3 times negative 4 is now plus 12. And then over here, we don't multiply by anything. Okay, so I don't need the denominator anymore because I found a common denominator. So now we're at 7x plus 12 equals 7, subtract 12 from both sides. 7x equals negative 5, meaning x equals negative 5/7. Okay, more of the same. So this time I see that this needs a 6 over 6, and this is x minus 1 over x minus 1. Okay, so that leaves us 24x plus x minus 1. So this time it's a plus sign, so I don't really need to worry about distributing. Okay, so that means 25x minus 1 equals 3x. So let's see, subtract 3x over here, and then add the 1 over. So then x would equal 1 over 22, which is choice C. 3x over x minus 2 minus 1/3 equals 4 times, or 4 over 3 parentheses x minus 2. Okay, so this first term needs 3. The second term needs x minus 2. Okay, so first term becomes 9x. Second term, I'll keep the minus for now. Okay, so this negative gets distributed out. Negative x, but then negative times minus 2 is now plus 2. Okay, so we got 8x equals, subtract 2 over, and x equals 2 over 8, which reduces to 1/4. Okay, here, this is 3 parentheses x plus 1. So this needs 3 over 3. This needs x plus 1 over x plus 1. Okay, so that gives us 15x plus, I'll just distribute out 2x plus 2 equals 1. 17x equals negative 1. X equals negative 1/17. Okay, simplifying state excluded values, so let's factor first. So numerator and denominator. Okay, so both of these are excluded values. So remember, we want to do that before we before we reduce. Okay, so now we can reduce this part out. So it's x plus 4 over x minus 3, but I made a mistake. None of the excluded value choices are fully correct. So these are supposed to be the excluded values. So I said the answer was E. So negative 4 is not an excluded value. We do not care if the numerator turns to 0. That's okay. It's only when the denominator turns into 0. Okay, so again, we got a factor. Let's see, we got 2x and x, and then minus 4 plus 1. And in the denominator, let's see, minus 4 plus 3 should work. Okay, so again, we do excluded values before simplifying. So here x could be 4, but then also x could be, that's a comma, negative 3 over 2 for this one. And then now we can reduce these away, leaving b as the answer. Okay, so again, excluded values first. If x is 0, then the whole denominator becomes 0. But also if y becomes 0, the whole denominator becomes 0. Okay, so now what can we reduce? 8 divided by 2 is 4. X over x to the 6th over x to the 4th. So if you cancel out 4 x's from each, you're left with x squared up top. And over here, you've got y times y on top, and y used 6 times on the bottom, so you get rid of 2 of each. You're left with y to the 4th in the denominator. Okay, so that looks like choice C. Okay, so excluded values first. A can't be 0, B can't be 0, because those would make the denominator 0. So now what can we reduce? 15 and 10 can both be divided by 5. A to the 8th over a to the 16th. Get rid of a to the 8th from top and bottom. That uses up all of them on the numerator, but that means there's none left in the denominator. There's 8 left over in the denominator. And then b to the 7th over b to the 1st. Get rid of 1b from each. You're left with b to the 6th. So that would be choice B, but again, I made a mistake. B equals 0 is also an excluded value, because even though there's no b in the denominator at the end, we look at the original function. Okay, so here's a work problem. These two people are working together. So formula, the time together is unknown, but Erin would take 8 hours by herself. Alvin would take 6 hours by herself. So set that equal to 1. Let's get a common denominator. Oops. So this 3t plus 4t all over 24 equals 1. Multiply both sides by 24. So 7t equals 24. T is 24 over 7. And finally, let's see, Eunice is shook, and then it takes her 5 seconds by herself, but if her friend had helped her, it would have only taken 3 seconds. Okay, so time together is 3 seconds for both. How long would it take Eunice's friend alone? Okay, so let's get a common denominator. Okay, so we have 3x plus 15 equals 5x. Over 5x. And then we set the numerators equal to each other. 3x plus 15 equals 5x. Subtract 3x from both sides. Divide by 2.